Hi guys, welcome back. This one is going to cover This video is going to cover two different concepts: the difference between laws and theories, and then we're going to talk about the three different forms of variables. So let's get into it. Scientific laws. Scientific laws. Remember, you can rephrase this as much as you want, as long as it's correct. It's a concise and factual statement that is meant to prove an observation. So these are what we know to be true. They have been tried and tested over and over and over again, and they're accepted to be true by all scientists. An easy way to find a law is they normally have a mathematical equation that goes along with it. Now, you can have laws without mathematical equations, but if that math equation is there, it's most likely a law. So I want you to think about an example of a law, write it down, and we'll come back to it. Now, theories, on the other hand, is simply an explanation of a natural or physical phenomenon. You go through multiple hypotheses that have been verified by independent researchers, but there's often something there that's not quite, it doesn't meet the standards all the time. So it's not a law yet. There's something else at play that we're not seeing, or something else that we can't explain or describe. But under most circumstances, this is the way we believe it to react. So theories often include laws to prove their point, but they're simply explanations. So an example of a law versus a theory. Now, this is a physics equation, but you have something with a math equation like force equals mass times acceleration. That is not something you need to know yet. That's more of a physics thing that you'll get into your junior year or your next year. But that is a law. We know that the force of something is a multiplication of the mass times how fast that object is going. Scientific theories. We'll throw a little chemistry at you. Let's go with atomic theory. And that'll be in Unit 4. But atomic theory is how we believe the atom looks, how we believe its structure is. Now, we can't physically go in and see an atom yet. The technology doesn't quite exist, which brings another point. We normally lack technology, or we were not there to see it happen. So you can take the Big Bang Theory. We were not there to see it happen. It's just somebody's explanation of an event. The technology, we cannot yet go in to see how an atom looks, how its structure is. We basically have computers that give us a mathematical explanation, and we assume that to be true because of different experiments and different laws that we have with us. So those are the two. Those can be kind of tricky. Once again, we'll get a lot more practice in class about laws and theories. Okay, your variables. You have three variables. You've seen them a lot throughout your years in school. We're going to do them again. So here we go. The independent variable is the variable that you are changing. That's the thing. You physically change the independent variable. And it affects the dependent. It's on the x-axis. Remember, it's the long line. So there it is. That's your x-axis right there. The big thing about it is that you are physically changing it, or the scientist is actually going and changing that variable. Because the dependent variable, on the other hand, is what is going to be measured. They are the results of your experiment. That's a good way to keep the differences, to decipher between independent and dependent. You change the independent, you measure the dependent, and you record your results of the dependent variables. Now, control variables, these are different variables that are held constant to allow comparison of only the independent versus the dependent variable. Now, they are not control groups, they're just control variables. For instance, a control group, you take a medication, a control group is going to be a placebo group that is not going to be given a certain type of medication, while the new cancer treatment is going to go to a whole other group. Control variables are something like temperature. I'm going to control the temperature in this room as I use two different waxes on the floors. That's going to be controlled. Humidity, pressure, all those things are going to be controlled variables. Yeah, there it is in the bottom there. So now you've got a little claim at the bottom that says practice. Guaranteed to pick up 20% more of your dirt than other leading bagged vacuums. So you go ahead and pause it, go through those questions, and we'll come back and we will talk about them. All right. So how do we test the claim? Well, we're going to put down a set amount of dirt. We're going to have several brands run over the same amount of dirt to make measurements initially and after the vacuum passed over it. So we're measuring how much dirt each one of these brands is actually sucking up. Okay. What would your beginning question be? Well, which vacuum picks up the most dirt? Or you could say, does this brand actually pick up 20% more dirt than the other bagged vacuums? Something along those lines. Now, your independent variable. Remember, this is a variable that you are changing, or the scientists can change. You're going to change the brands of the vacuums. So the different styles, the different types of vacuums. You're not going to change the dirt. You're not going to change the amount of dirt, just the type of thing that's rolling over it that's going to be actually doing the dirt picking up. A dependent variable, remember those are results, the things that you're measuring. That one's easy and pretty set in stone. This one is your amount of dirt. So you're going to pick up the bags. You're going to either do it by mass or by volume, however you want to determine 20% more. You're just going to measure that as your result. So control variables, you can have a lot of control variables that you can pick from. You got to use only bagged vacuums. You have to use the same kind and the same amount of dirt. You have to spend the same amount of time over the dirt. So you can either run it over real quick once, or say you're going to spend 30 seconds over this dirt and just see if you're just going to leave it there, see if it picks up more dirt as time's there. Also, the floor that's on. You don't want to do one on carpet and then do one on tile. Vacuums work differently like that. Power source. Make sure they all have the same power source, the same amount of power going in. There's a lot of control variables. So I hope you see the difference there between a control variable versus a control group as well. So that's all with this video. If you got questions, once again, we'll work through these a lot in class. And if you got questions, please come and talk to me next class.